NENOMATICA, where mathematics meets YouTube excellence. Scientific notation. Welcome to our lesson on scientific notation. Scientific notation is a way of expressing numbers that are very large or very small in a more compact form. It's especially useful in science, engineering, and mathematics. Scientific notation follows a specific format. We write a number as a product of a coefficient and a power of 10. The coefficient is a number greater than or equal to 1 and less than 10. And the power of 10 shows the decimal place value. Let's look at some examples from the exercise. First, let's see how to write large numbers in scientific notation. Let's start with our first example, 5,432 times 10 to the power of 12. We need to convert this to scientific notation. In scientific notation, the coefficient must be between 1 and 10. Right now, our coefficient is 5,432, which is greater than 10. To fix this, we need to move the decimal point to get a number between 1 and 10. We move the decimal point 3 places to the left, which gives us 5.432. When we move the decimal point 3 places to the left, we need to increase our exponent by 3. So we add 3 to our original exponent. 12 plus 3 gives us 15. So our final answer is 5.432 times 10 to the power of 15. Now, let's look at our second example, 0.0672 times 10 to the power of 14. Again, we need to check if our coefficient is between 1 and 10. Here, our coefficient is 0.0672, which is less than 1. So we need to move the decimal point to get a number between 1 and 10. We move the decimal point 2 places to the right, which gives us 6.72. When we move the decimal point 2 places to the right, we need to decrease our exponent by 2. So we subtract 2 from our original exponent. 14 minus 2 gives us 12. So our final answer is 6.72 times 10 to the power of 12. For our third example, we have a large number, 10,234,560,000. To convert this to scientific notation, we need to move the decimal point to get a number between 1 and 10. We move the decimal point 10 places to the left, which gives us 1.023456. Moving the decimal point 10 places to the left means we need to add 10 to our exponent. Since we're starting with no explicit exponent, we're essentially starting with 10 to the power of 0. 0 plus 10 gives us 10. So our answer is 1.02345, 6 times 10 to the power of 10. Our final example is 24,087.64. Like before, we need to move the decimal point to get a number between 1 and 10. We move the decimal point 4 places to the left, which gives us 2.408764. Moving the decimal point 4 places to the left means we add 4 to our exponent. Starting with 0, we get an exponent of 4. So our answer is 2.408764 times 10 to the power of 4. However, the example shows some other ways to write this same number. We can express it as 24.08764 times 10 to the power of 3, or as 240.8764 times 10 to the power of 2, or even as 2,408.764 times 10 to the power of 1. These are all mathematically equivalent, but only the first one is proper scientific notation, since the others don't have coefficients between 1 and 10. Let's summarize the process for converting a number to scientific notation. First, move the decimal point so that there is exactly one non-zero digit to the left of the decimal point. Next, count how many places you moved the decimal point. Finally, multiply by 10 raised to the power of that count. If you moved the decimal point to the left, the exponent is positive. If you moved it to the right, the exponent is negative. Scientific notation is especially useful in many fields. In physics, we use it to represent very large distances like the distance from Earth to the Sun, which is approximately 1.5 times 10 to the power of 11 meters. In chemistry, we use it to represent very small masses like the mass of a hydrogen atom, which is about 1.67 times 10 to the power of negative 24 grams. And in astronomy, we use it to represent the enormous number of stars in the observable universe, estimated to be around 1 times 10 to the power of 24. In conclusion, Scientific notation is a powerful way to represent very large or very small numbers in a compact form. Remember the key rules. The coefficient should be between 1 and 10, and the power of 10 indicates how many places to move the decimal point. Practice these conversions, and you'll soon be comfortable working with scientific notation in various contexts. Thank you for watching. Scientific notation is a powerful way to write very large or very small numbers in a compact form. Scientific notation expresses a number as a product of a coefficient between 1 and 10 raised to some power. The general form is a times 10 to the power of b, where is a number between 1 and 10, and b is an integer. For example, let's convert the number 5,280 to scientific notation. We move the decimal point to get a coefficient between 1 and 10. Since we moved the decimal point 3 places to the left, our exponent will be positive 3. So 5,280 in scientific notation is 5.28 times 10 to the power of 3. Let's solve an exercise where we need to order numbers from smallest to largest. Here we have 4 numbers in different notations. 9.89 times 10 to the power of 4, 99,000, 1 times 10 to the power of 5, and 98 times 10 to the power of 3. To compare these numbers, we'll first convert them all to their standard form. Let's start with the first number, 9.89 times 10 to the power of 4. This means 9.89 times 10,000, which equals 98,900. The second number, 99,000, is already in standard form, so we don't need to convert it. The third number, 1 times 10 to the power of 5, means 1 times 100,000, which equals 100,000. The fourth number, 98 times 10 to the power of 3, means 98 times 1,000, which equals 98,000. Now that we have all numbers in standard form, let's arrange them from smallest to largest. We have 98,000, then 98,900, then 99,000, and finally 100,000. Finally, we can write our answer using the original notations. The correct ordering from smallest to largest is 98 times 10 to the power of 3, 9.89 times 10 to the power of 4, 99,000, and 1 times 10 to the power of 5. Here's a helpful tip for comparing numbers in scientific notation. First, compare the exponents of 10. A larger exponent means a larger number. If 2 numbers have the same exponent, then compare their coefficients. In conclusion, ordering numbers in scientific notation requires, first, understanding the components of scientific notation, the coefficient, and the exponent. Second, converting numbers to the same form for easy comparison if needed. And finally, comparing the exponents first, then the coefficients if necessary. With these skills, you can confidently order any set of numbers, no matter how large or small they are. Welcome! Today we'll solve a problem about comparing the masses of the Earth, Moon, and Sunday. Let's look at the problem statement. Our problem states that the masses of the Earth, Moon, and Sun are approximately equal to the following numbers in kilograms. Earth, 6.0 times 10 to the power of 24 kilograms. Moon, 7.34 times 10 to the power of 22 kilograms. Sun, 2.0 times 10 to the power of 30 kilograms. The first question asks, how many times is Earth's mass greater than the Moon's mass? Let's solve the first question. We need to find how many times the Earth's mass is greater than the Moon's mass. To do this, we'll divide Earth's mass by the Moon's mass. 6.0 times 10 to the power of 24 divided by 7.34 times 10 to the power of 22. When dividing numbers in scientific notation, we divide the coefficients and subtract the exponents. First, we divide 6.0 by 7.34, which gives us approximately 0.817. Then, we subtract the exponents. 24 minus 22 equals 2. So, the Earth's mass is approximately 0.817 times 10 to the power of 2, which is about 81.7 times greater than the Moon's mass. We can round this to about 82 times greater. Now, let's solve the second question. We need to find how many times the Sun's mass is greater than Earth's mass. We'll divide the Sun's mass by Earth's mass. 2.0 times 10 to the power of 30 divided by 6.0 times 10 to the power of 24. First, we divide the coefficients. 2.0 divided by 6.0 equals 0.333. Then, we subtract the exponents. 30 minus 24 equals 6. So, The sun's mass is approximately 0.333 times 10 to the power of 6, which is about 333,000 times greater than Earth's mass. We can write this as 3.33 times 10 to the power of 5. Welcome to this lesson on scientific notation. Today we'll learn how to represent very large numbers in a more compact and convenient way. Scientific notation is especially useful in astronomy, physics, and other sciences where we often deal with extremely large or small quantities. Scientific notation is a way of writing numbers that are too large or too small in a more concise form. The format is always a number between 1 and 10 multiplied by a power of 10. For example, the number 695,000 can be written as 6.95 times 10 to the power of 5. Let's start with our first example problem. The radius of the sun is approximately 695,000 kilometers. Let's write this number in scientific notation. First, we identify the original number, 695,000 kilometers. To convert this to scientific notation, we need to move the decimal point so that there's exactly one non-zero digit to the left of it. In 695,000, we need to move the decimal point 5 places to the left. This gives us 6.95. Since we moved the decimal point 5 places to the left, we multiply by 10 to the power of 5. So 695,000 in scientific notation is 6.95 times 10 to the power of 5. Before we move to the next example, let me quickly explain the powers of 10. 10 to the power of 1 is just 10. 10 to the power of 2 is 100. 10 to the power of 3 is 1,000. And so on. We can also have negative powers of 10. 10 to the power of negative 1 is 1/10 or 0.1. 10 to the power of negative 2 is 1/100th or 0.01. So positive powers of 10 move the decimal point to the right, while negative powers move it to the left. Now let's move on to our second example. The diameter of the sun is about 1.4 times 10 to the 9th meters, while the diameter of the Earth is about 1.3 times 10 to the 7th meters. How many times is the sun's diameter greater than Earth's diameter? To solve this, we need to divide the sun's diameter by the Earth's diameter. When dividing numbers in scientific notation, we divide the coefficients and subtract the exponents. So we have 1.4 divided by 1.3 times 10 to the power of 9 minus 7. 1.4 divided by 1.3 is approximately 1.07, and 9 minus 7 equals 2. So we get 1.07 times 10 to the power of 2, which equals 107. Therefore, the sun's diameter is about 107 times greater than Earth's diameter. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.